with this small group here, just section 6.3, as soon as you wrap up that problem. And section 6.3 is about proportions. And the title is Understanding Proportions. My S got disconnected. Okay, so this is actually something that you have been working on for months, understanding proportions. So it should be just one more little thing that we add to the mix. Okay? So I bet if I ask you to give me some examples of proportions, you could do that. Does anybody have an idea of what makes something proportional? Yeah. So not looking at so much, not so much looking at those problems, but just thinking about what's proportional. Like, if I asked you if you could find something that's in the same proportion as 2 to 3, can you guess what that might mean? Yes. Yeah. It's kind of hard to hear because of the other groups in the class, but she said 2 to 3 is the same as 4 to 6. So understanding proportions really means, do you know how to get equivalent ratios? If you have equivalent ratios, if you have 2 equivalent ratios, like this pair, then you have what we call a proportion. This forms a proportion. 2 equivalent ratios makes a proportion. It's just like another vocabulary word. Sammy.
What if there's 3 equivalent ratios? Is that still a proportion?
Yes. So they usually come in 2s. So you look at them 2 at a time, but I have an example with 3, and we're going to look at both. Michaela. So, how did she get that? You could get all kinds of proportions. She picked 2s. But there's other proportions, like she could have also like tripled this, for example, which would give me 12 and 18, right? So what we could say is 2/3 and 12/18 form a proportion. Okay? So you can use all of your old skills just with the new vocabulary word. So we're going to look at the vocab. Okay, so I'm not sure where we left off. I just paused that. But the goal today is to be able to answer questions like these. Can you tell if these form proportions? So if I give you 2 ratios, you have to decide if they are proportional. And then go back to the old stuff. Can you find the missing value, which we've already worked on? And then the third thing is Sammy's question. Can you do the same type of thing with 3 pairs of ratios? So those are the goals. Really, the only new goal is number 1. So how do you think you're going to decide something's proportional? Yes? You can try that. Yeah, you can see a 6 goes into 27. In this case, it doesn't go in evenly, but that's a great idea. So one idea is, can you build build this to become this. So in this case, that's pretty hard. But that's the right idea, because sometimes you can build it up. Another idea is to put one of them into a ratio table. And a long time ago, we talked about some steps of reduce down first. And then what happens? What will we do next? Reduce down. What's the next thing? Hold on, let's go. What would the next step be? And see if you could build up. So can you take this problem with your ideas and reduce down? And then I'll answer your question, Michaela. Oh, okay. 5 by 2. And so this becomes 3 and 8, right? And the goal would be to get a 27, right? So can we get that 27 now? Yes. So you would. You'd have to multiply by 9, right? So then you have to multiply 8 by 9. And 9 times 8 is 72. So we have 72 over 27 is the same as 16 over 6. So do those form a proportion? Yes. And that's why you would answer the question, and you would show that you could get from one ratio to the other somehow. And if you can, you would answer yes. 72, 27, and 16, 6 are proportional. Now your book, what your book does is they write it with a comma. Look at that. They don't put an equals for you. In your book, what they do is they put a little comma here, and they turn this into a question. They say, are 3/5 and 8/13 proportional? Or they might say, do 3/5 and 8/13 form a proportion. But I wanted to start with what we've been doing. Your book is really going to probably ask you to do it this way. So what you need to do is then remember this. You know, you've got to think that through, that this becomes an equals. So that's what you're, yeah, so when you read that problem in your homework, you're going to really write this problem. And maybe put a question mark here. Are these equal? And sometimes you can't use Sammy's strategy here. This was a little harder, but you could try to build, you could try another strategy. So it's great if you could reduce down to build up. But in the second example, that doesn't work, so can you come up with another strategy? Yes.
Well, I just have a question. Is it easier to use a lower fraction first, like using ratio table, rather than the higher one?
Sometimes it's actually easier to use the higher one and reduce down. It just depends. I think you just have to look it up and kind of take a chance and go with it. But sometimes that strategy of reducing down and building up works really nice. Sometimes they're already reduced down. So there is a build up that you can do. So here you might need to build up to a special type of denominator. What would that be? Perfect, right. So sometimes building up means make a common denominator. What's the common denominator here? 5 doesn't go into 13. Remember the ladder? 5 and 13 have only one in common, right? So what's the common denominator?
5 times 13.
5 times 13. It has to be 5 times 13.
Which is
Remember, you can do that with an area model.
65.
There you go. 5 times 10 is 50. 5 times 3 is 15. So the answer would be 65. Do you understand that? Can you guys see what I'm doing here? So I would have to build this up with a common denominator, just like when we added fractions. So I would have to take the 3/5 and multiply the 5 by 13 over 13. And then I would have to take the 13 and multiply it by what? 5 over 5. So this is 39 over 65. What about this? What's 8 times 5? 8 times 5 is 40. Okay, so we have 39 65ths and 40 65ths. They're very close, aren't they? But they're not proportional, because they're not exactly the same. So the answer is that 5 3/5 and 8 13ths are not proportional.
They have to be exactly the same.
You know, one thing I didn't do, that I'm going to move this to the next page. One thing I didn't do is remind you that sometimes it might even be easier if you could recognize benchmark fractions. Like maybe you would see 7/10 and 3/4, and you might ask, are these proportional? So we could reduce down and build up if it's possible. So that was our first thing. You always want to see if you can reduce down. Maybe you want to think about, can you build up? Maybe you want to make a common denominator. Or maybe you want to use benchmark fractions. Those are really your 4 options. You don't have to use all 4 things. These are your strategies. If you can use benchmark fractions, that's quick. We don't ever want to stop using benchmark fractions. What's the fraction for 7/10? So we're still asking the same question. We want to know if these are equal, but what's the benchmark fraction?
70.
70? 70 is not even a fraction.
0.7.
0.7, right? 0.70 is what you mean, right? What's the benchmark? 0.75,
So they're
right?
not equal.
So they're not equal. We didn't have to do those harder steps because we recognize benchmark fractions. So we just say 7/10 and 3/4 are not proportional. So we have to get to see if they're equal. So look at all of let's look at the things that we did here. We took the first example and just used the ratio table to see that we could make them equal. Okay? So that works when you can reduce down and build up. Right here. So this one works with reducing down and building up. Okay? Second example, there was nothing to reduce down right here. So we went to common denominators. Once we got the common denominators, we could answer the question. Third example was right here. We used benchmark fractions. Once we got to the benchmark fractions, we could answer the question. So your job is to pick the easiest way. Always try to go to the easiest way. Does that make sense? Jackson, you with us? Eric? You doing the notes? Okay. Then I think you know how to do the missing numbers. We've been practicing those.
I think we did that like last week or something.
So let's just make sure we have 5 more minutes, right?
Yeah,
It's a Wednesday. Let's just take a look at these. Why don't you guys try those real quick? Maybe one of you could do it.
I'll do it.
You want to do this one first?
Yeah.
So what's a quick way to do that? Here you go.
Oh wait, first one?
Yeah. What's a quick way?
Well, 5.
You can stick it in a ratio table if you want to take steps. So she's going to put 3/5 into a ratio table. Okay, so she's going to put in a ratio table. Sarah?
46.
Sarah? 48. So the missing value is 48. Okay, Sammy, what else you could have done if you couldn't come right up to 80, you could have times by 4. Yeah, that might have been easier if you got really stuck, and then times by 4. And you still get the right answer. So good job on that one. Nice job. Let's shrink that up. Make it a little mini. Okay, so this one's a little easier over here, right? What do you have to do, Justin? It's actually kind of, in some ways it's easier, some ways it's harder. Divide by 4. So how do you divide 7 by 4? Well, how many times did 4 go to 7? Once. Go to 1. And what's the remainder? No, it's 3. What? So 4 goes into 7. It's not, remember, remainders aren't decimals. So 4 goes into 7 once. Your remainder's 3, so you have a fraction. What's the fraction? 1 and 3. Yeah. So put the 3/4.
Yeah, I like the pizza. So do I.
Okay, so your answer is
I did not pass it. I only
I'll leave it 0.7.